G period physics. What's up? Last video. The tubes have a length of 0.3 meters. Okay, so here's the idea. We've got these half-open tubes, so they're closed on one end. And of course, these make the harmonics all messed up. So actually, and I'm sorry, I should have actually been clearer that the figure below applies to problems 13 and 14. So that was the whole point of this. So if you want the wavelength of each of the harmonics, we're going to be using the harmonic formula for tubes open at one end. That's actually going to be take L, you times it by 4, and then you divide it by the number of the harmonic that you're at. And this is only for odd n. Okay, so the idea here is for lambda 1, it's simply going to be 4 times 0.3 divided by 1, and that's going to give us 1.2 meters. Similarly, for lambda 2, it's going to be, lambda 3, that's going to be 4 times 0.3 divided by 3. And when we actually figure that one out, it's going to be 0.4. And then when you actually get lambda 5, I'm just going to go ahead and write out the answer. You know how to multiply. It's going to be, I got 0.24. So you may know how to multiply. Double check my number and make sure that I got that right. And then the speed of sound is going to be 340. So to get the harmonics, we can keep it really simple. You actually don't have to solve the sound equation every single time. Just get the frequency of the first harmonic. So we'll say 340 equals lambda 1, which is 1.2 times f. And when we actually do that, we'll end up getting a frequency of 283.3. So that's f1. And then we can actually get the frequencies by multiplying. So f3 is going to be 3 times 283.3. And that's going to give us about 850 hertz when I round it. And then lastly, f5 is where I'm going to take 5 times 283.3. And that's going to end up giving me 1,416.7 hertz. So that pretty much wraps up this practice test. I want to get these videos online, and now it looks like I get to talk real physics with somebody, so let me take care of that.